This is exercise 5 on page 475. We have this region in the plane defined by x equals 0, y equals 0, and x plus 2 is equal to 4. When we the x equals 0 is the y-axis, y equals 0 is the x-axis, and this is the line x plus 2y is equal to 4. You can see that when y is 0, x is 4, so I get this point here. And when x is 0, y is equal to 2, so I get this point. So we're looking at our region is this green triangle. The area of this green triangle is 1/2 the base times the height, which is 1/2 of 4 times 2, which is equal to 4. So in our formulas for the x-coordinate of the center of mass and the y-coordinate of the center of mass, we know that the area down here is 4. Also, in these formulas, my top curve, right here, this line, is, if I solve this equation for y in terms of x, we send the x over to the other side, divide through by 2, and I get that the y is equal to 2 minus x over 2. So f is going to be this, and g is going to just be the y-axis, or 0. So using this formula here for x bar, we will write x bar is equal to the integral from a to b, well, that's going to be 0 to 4, of x times f. F was 2 minus x over 2, and we're integrating with respect to x. We're also going to divide through by the area, which is 4. So when we simplify that, I get 1/4 of the integral of, when I multiply that out, I get 2x minus x squared over 2. And we integrate from 0 to 4 again. So when we integrate, we get 1/4 of the antiderivative 2x is x squared. Antiderivative of x squared over 2 is minus x cubed over 6. When I evaluate at those endpoints and take the difference, this becomes 1/4 of 16 minus 64 over 6. There's a 4 in each of those, so we'll write this as 16 over 4 is 4. 64 over 4 is 16, so 16/6 is 8/3. And 4 is 12/3, so I come up with 4/3 is the x-coordinate of the center of mass. Now let's go for the y-coordinate of the center of mass, which is equal to 1/2 of the integral, just following this formula here, from 0 to 4 of the square of f. So I get 2 minus x over 2, the quantity squared, dx. And then we divide all that through by the area, which is 4. Okay, well, 1/2 divided by 4 is going to be 1/8. And the antiderivative of 2 minus x over 2 all squared would be 2 minus x over 2 all to the 3rd power, and I divide through by 3 because of this 3 up there, and we multiply through by a minus 2 because of the minus 2 underneath that x. So I get a minus 2. Or we could use the chain rule or a substitution. So I want to evaluate at 0 and 4. Now, when I do this, I get, there's a 2 over an 8, so I get a 1/4, and then there's a 3 down there, so I get a minus 1/12. So this would be a minus 1/12 of 2 minus x over 2 to the 3rd power, 0 to 4. So I get a minus 1/12. When I evaluate this thing at 4, I'm going to get 0. So I get 0 minus this thing at 4. So I get 2 cubed, which is 8. oops, I dropped to 12 here. So I get a minus 8, or 8 over 12, and I got 2/3 for the y-coordinate. And actually, whenever we do this problem up here, if we have a right triangle like this, where the x-axis, or the x, or this point right here is A, and this point up here is B, the center of mass is going to be at A over 3 and B over 3 as the x and y coordinates.